Hello and welcome to Math 140. We are going to continue Chapter 5. This is your instructor, Cindy Enrique, and we are learning remotely online. So here we go. So section 5.2, it's all about the introduction to polynomials. So we're going to fill in the blanks. We're going to get used to our vocabulary words here. So a blank is an expression that is a constant or a variable. So unfortunately, I have some typos here. So that's a typo because I say constant twice. So it's a constant or a variable. And it's also a one-term polynomial. It also has positive exponents on the variable. And so that vocabulary word that we're looking for is polynomial. Our second vocabulary, it says a blank is the numerical or constant factor in a term. So that is going to be the coefficient. The third one is the blank relates to the exponent of the variables. So when I'm thinking about the exponent, then I know I'm going to be talking about the degree of the exponent. Okay. The degree of monomial is the biggest of the exponents of all the variables in a monomial. A blank is a monomial or a sum of monomials. So, sorry about that. So a monomial or a sum of monomials, that's a general term of saying polynomial. And here, if the polynomial has two terms, then it's called a binomial. And if a polynomial has three terms, then it's called a trinomial. Okay. And that's for our vocabulary words. So let's use these vocabulary words and let's put them into play to determine whether or not the examples below are polynomials or not. So really, you want to make sure whether something's a polynomial. You want the exponent to be a positive whole number. So those are their two criteria, positive and whole number. So for the first one, let's see. It says 5x plus 1. Well, look at the exponent. The exponent on x is actually 1. Therefore, it's positive and it's a whole number, so yes, this is a polynomial. For the next one, let's look at our exponent. The exponent is 3 and the exponent is 5. Those are positive and whole numbers. Therefore, it's yes. It is a polynomial. Now, let's look at something else here. See this exponent? That exponent is a -6. We do not like an exponent that's negative. So here, my exponent is negative. And because it's negative, it is not a polynomial. And for the next one, this part D, this 1 over x. Well, from our rules of exponents that we learned in section 5.1, we know that we can rewrite this. 1 over x is really x to the -1, which tells us that the exponent here is negative. We don't like that. Therefore, it is not a polynomial. And for part E, when I'm looking at that, I'm looking at it and I see that the exponent is 3/7. So here the exponent is 3/7. It is not a whole number. Therefore, it is not a fraction. So hopefully those are some nice little examples to show you what is a polynomial and what is not a polynomial. You just have to really pay attention to the exponent. Okay? Now, for example number 2, it says indicate whether the expression is a monomial, binomial, trinomial, or no special polynomial name. Identify the degree of the polynomial, and identify the leading coefficient of the polynomial. So part A. I know that this is a monomial because there's one term, and terms are separated by addition and subtraction. So terms are separated by addition and subtraction. So since there's no addition or subtraction in number 1, then I know it's one term, therefore it's a monomial. For part B, the exponent here is really an invisible 1, so we're going to say that this is going to be the exponent of 1, so my degree of the polynomial is 1. It's all about the exponent. That's going to be our degree. And the last part, it specifically is asking us for the leading coefficient. So the leading coefficient is the number in front of the variable. So that's going to be 4. That is the leading coefficient. Now let's look at problem number 2. So for this example, I want to see how many terms this has. So I have 1, 2, 3, 4 things that are being separated by addition and subtraction. So because I have 4 terms, it can't be a monomial or a binomial or a trinomial, since trinomial has 3 terms. So when it's more than 3 terms, we just say it's a polynomial, which means more than 1. So not a special term. So then our second thing, we want to identify the degree of a polynomial. So we have 3, 2, 1, and 0. So this is the biggest exponent. So that tells us that it's going to be the degree. So the degree of this polynomial is 3. And the last thing we want to look at is the leading coefficient. The leading coefficient is in connection to the biggest exponent. So here, this 2 is going to be my leading coefficient. So the leading coefficient here is 2. Hopefully that helps you out a little bit to understand our vocabulary. And we have some practice problems, but practice problems are usually done in class, and since we don't have that time in class to work together, make sure that you guys do this on your homework, okay? You will see plenty of this on your homework. Now, for example number 3, we want to combine like terms and write the resulting polynomial in descending order. So that descending order, what that means is write it from biggest exponent to smallest exponent. So write from biggest exponent to smallest exponent. Okay. So we want to combine some terms together. So here I have a 10x3 and a negative x3. So those are going to be my x to the 3 power. So I have my 10x to the 3 and my negative 3x to the 3. The second thing I'm going to be looking at is my degree 2. So there's my degree 2 and there's my degree 2. So I can say it's a negative 4x squared and a negative 5x squared. The other thing that I'm going to have here is a just regular 6x. So that 6x doesn't combine with anything else, so it's a positive 6x. And everything that's left over is a constant. So I have a positive 8 and a negative 9. So when I combine like terms, I'm going to have 10 minus 3 which is going to give me a 7x cubed. Now I'm going to have a negative 4 minus 5, and that's going to give me a negative 9x squared. And I have my 6x that didn't combine with anything. Let me just change the color here to keep it constant. So I have my positive 6x. And the last thing I have is 8 minus 9, which is going to give me my negative 1. So that's going to give me my final answer. So I have 7x cubed minus 9x squared plus 6x minus 1. I want to make sure that things that are added and subtracted together have the same degree and the same variable. Otherwise, I can't add and subtract them. Okay. So more practice problems for you guys. I'll leave that up to the homework on Newton. And section 5.3 will be in our next video. Stay tuned.